but obviously the on the ground stuff. So a lot of what we've talked about so far has been focused at the well and well field scale. I want to step back for just a couple minutes and talk about the long-term supply planning, and a little more that comes a little more from a regional, resource protecting our aquifer kind of perspective because of the importance of that supply. And I was thinking about, again, why often are we asked to build models and what are people wanting to do with them? And when it comes to the stuff other than wells and well field optimizations, kind of boiled it down to really two big things. One is, and I think people in this region from, say the last 10 years, I've done some projects off and on over the years, you're all very aware of the externalities that influence the aquifer system. The aquifer sits inside a larger watershed. And years like 2015 came along, and now this one, where it's unusually dry, didn't get the big spring runoff. City of Spokane in particular in 2015, noticed some abnormally low water levels in their wells, and it kind of got them thinking, we need to take a little harder look at the resiliency of the supply we have relative to our hardware, but also to the aquifer itself. So we're tending to look a lot at climate change influences, which is not just kind of what classically hydrogeologists think about, which is, how does the rainfall and the stream flow affect the aquifer? I'm actually finding a lot of the work I'm doing these days, temperature is a big deal because it's changing customer water demands, therefore changing the way we're using wells and having to think about demand and supply management. And the models we build are being done to help guide decision-making and management. And then you superimpose growth influences like what all is happening here with just the tremendous growth that's going on, and what that means for what the demand profile looks like, how much, the seasonality of it, and how conservation should perhaps start fitting into that, maybe in a little different way than has been done in the past. And then the other thing, and this is a little more on the Washington side, there's certainly been, studies that we've done to help understand the relationship between the river and the aquifer during the low flow season. And that's because in Washington, there is a real dynamic and close coupling of those two systems. Just kind of a quick visual example of that latter point is right here from some work we did with some of the SAJB members last year, more just kind of, not last year, about 7 years ago, just kind of helping them think through and understand more from a hypothetical perspective, what if a water district had two wells, one kind of close to the river, one farther away. Let's say they're in the same pressure zone. Could they maybe use one a little more that's farther away from the river than they're accustomed to using and back off a little on the one close to the river during, say, the summer season when we're all concerned about low flows in the stream? And so we could do analyses where we model that idea of how to kind of geographically distribute the pumping and start looking at the results in a time sense of, what kind of percentage benefit during these peak seasons are we having, for every, let's say, 1 CFS of pumping, are we getting, in this case, about 50% of that 1 CFS is an increase in river flow. That's been kind of a helpful thing for some utilities to know. Now, I'm going to show something from the city of Spokane, a little bit related to that, but partly related to water quality. As probably most of you know, the electric well field over by Upriver Dams, it's very close to the river, big caisson wells, as Kenny showed some of the pictures of. We were involved in a study about 3 years ago where we did installed a couple test holes and started thinking about, would a vertical well field in this location make sense for the city? And the reason they were thinking about it was that when the flow in the Spokane River gets above a certain amount, I don't remember the exact number, it's either
15,000.
15,000 CFS, they automatically have to turn off the well electric facility because of connection with the river and microparticulate concerns. So that means they can't use that well field at times and when they may want to. So we started doing some work to investigate whether a vertical well field might make sense. And we identified various sites that, you could maybe think about putting some wells. Did a test well out there, and much to our surprise, and really got Dan and I super excited when we discovered this, was the aquifer wasn't quite as simple as we thought it was. Turned out there's a gravel unit like we all know and we're all used to seeing, but at that spot at least, you go down about 150 feet and there's a fairly thick sand unit down there. Very different characteristics. Still look to be pretty permeable. And we started thinking about, gosh, what could a well field look like? And we came up with some, sort of just a rough prototype design of how might you construct it, how deep might you, put the top of the well screen and the bottom of the well screen. And then we took our 3-layer groundwater model, carved it up into an 8-layer groundwater model so we could start thinking about screen depths in some detail. And then started using the model to say, okay, if you pumped that well field and or the caisson wells in various ways, where does the model think that water might be coming from? So tracing the actual groundwater flow paths to the well. And what you're seeing on the left is a view where those yellow particles are showing where the water is getting to the caisson wells, which in this particular model, the yellow color meant they're staying up in that shallow gravel unit and they're pulling water, partly from the river. But that well field down in kind of that lower right and lower center area where all those other different colors are, the model was saying if you're screening down that deep, there's a good chance you're pulling water from a completely different direction. You're not pulling it from near the river. And if it is going to intercept river water, it's going to intercept it somewhere off that map, some distance away. And the plot on the right was just a cross-sectional view of the same thing, showing that, in the white, the shallow caisson wells, basically all their flow paths are staying shallow, but the deep wells, all their flow paths are staying deep until, somewhere, maybe here in Idaho, who knows, they become shallow. So this got the city pretty excited. And of course, the one thing you all have to do is remember it's a model, right? So one of my earliest mentors, who was a groundwater modeler, kept saying, now, John, if you believe your models to the 15th decimal point, we're going to have to send you to Modelers Anonymous. Remember, there's always uncertainty in these things. And what helped us feel like we were onto something was that we had some data out here in those test monitoring wells, where in the green line, what we're plotting on this plot is groundwater elevations on that left vertical axis and showing what they are for a well, the monitoring well in the deep sand in green, the shallow gravel in orange. And you can see that the groundwater levels are about 2 feet higher at all times. This was over about a 2-month monitoring period that also coincided with when the river was coming down off the spring freshet and starting to stabilize, to something lower. So both units were tracking what the river was doing, but we have an upward gradient is this is telling us, is water from that deep zone wants to move into the shallow pressure zone, which means that deep zone is pressurized, which means it's pressurized from somewhere distant away, kind of verifying the idea that we might not be, very real indication we might not be anywhere near this river in terms of hydraulic connection if they were to do a vertical well field. So very exciting finding. Kind of related to all that, then you start thinking about, the condition of the aquifer, on a long-term basis. Everywhere in the West, people want to, and aquifer managers, water utility managers really kind of want to know, what does climate change potentially look like? And for those of you who were at the River Forum in 2016, you may remember some slides I'm showing here where we did some work to look at the data from the snow tell stations from 1980 through 2015. And we asked ourselves, gosh, what if you were to group the pre-2000 data in one group and the post-2000 data in another group and start plotting up the frequency of various snowfall amounts for that first period versus the second period? Do they look alike or do they look different? And we developed something month by month that showed in December, the more recent period in orange, seemed to be shifted farther left, meaning, and the horizontal axis is how much snow there is. The vertical axis is the number of occurrences of that much snow. And it's a snow water equivalent is what we're measuring at the snow tell stations. You can see that that more recent period, things were shifted towards less snowfall in orange than more snowfall in those earlier years in green. And if you just looked at that month by month through that whole data set, this was December, this was January, where you're seeing the snowpack building in both cases. Continuing through March, but then in April, we're past the buildup of the snowpack. We do still see a shift of that orange versus the green, and certainly by May, even quite a shift as well. And when we thought about this information and thought about the long record of flows at downtown Spokane, which go back a long, long ways in time, you could actually see, if you looked just at the 1980 through 2015 flows, you could draw very similar curves between what the snow water equivalent in the watershed in April typically looks like and how it's varied over that 35-year period compared to what the flows in August in downtown Spokane looked like over 35 years. And there's some mathematical fitting to those data sets because they're noisy data sets, but they're, you can actually tease out a relationship. And just the fact that you can do that makes a lot of sense, right? Because April snowpack in a large watershed, it makes sense it's gonna continue having an effect all the way through the summer. And that's what this is saying. So that has implications for the groundwater system too. And so that gets you thinking about, okay, that was the past, what does the future look like? And there's all kinds of tools now to, of course, to start understanding that future. This is just one of them, the climate mapper tool. And this is just what they call a box plot that looks at April snow water equivalents for various periods of time. So in this case, 1971 to 2000, 2010 to 2039, 2040 to 2069, and 2070 to 2099, looking at a whole ensemble of various climate models and what they say future snowpack in April might look like. That's snowpack on the vertical axis. So from 35 inches down to about 12 and a half. And you can see they're predicting a change, both in a case of where there's moderate future warming, what they call low future emissions, and then certainly in the case where there's high future emissions. And the tool also allows you to think about this kind of stuff spatially, where again, if you map out the highest snowfall amounts, snow water equivalent, I should say, on April 1st through this region historically, then looking into the future, and then looking out into the future, we can see some real differences as time goes on, which has implications for water management, including conservation, which Dan is going to talk about next.
Cool. I know, my apologies, I know we're running a little bit long here, but I just kind of wanted to talk about a couple of things that, and I think I jumped on my soapbox at the last meeting and talked a little bit about water conservation because it is something that's near and dear to my heart. But as you can tell from both John and Kenny's presentation, that there's avenues in which before we drill new wells, maybe rehabilitating or using modeling to, see how better to, if we do get to a new well scenario, where best to look to maybe lessen our footprint whenever possible. But certainly rehabbing well makes a lot of sense in the relationship of drilling another well and going through all that process. So go ahead. Wait for just a minute. This we got just a little. There it is. This is a really cool site. John gave me a call a few weeks back and pointed me to this. It's Droughtgov. Just Google it and it'll take you to the site. It creates a beautiful interactive map. But this is what we've been faced with. When I know Governor Inslee in Washington made a drought declaration in April, I was like, what? I'd never heard of a drought declaration in April. And then you look at what we're seeing today, this D4 categorized drought that exists today. And then I think it's the next slide kind of shows where we're at sort of stream flow wise throughout our region as well. And again, this Droughtgov, it has various different filters on the left that you can apply and it'll take you to other maps to different locations. But what we're seeing here is that all of the flows that flows in out of our watershed to feed our aquifer system are either low or below normal in just about everything that's feeding into this right now. And we can overlay that same thing with change the opacity on that drought monitor, and it really starts to paint that picture of what that D4 area looks like when it starts to overlay with some of those challenges that we have in the stream flow. So all of those yellow dots are well below normal stream flows, and some of the red dots are below normal as well. So it starts to paint a pretty drastic picture, just not only what Terry faced, with his pumping issues, trying to meet demand during this type of a drought period. There's probably reasons for that. I mean, when we got rain in Spokane, I'm sure it rained over here a little bit on Sunday. That rain probably didn't really penetrate soils much. I mean, it was probably gone and evaporated before you put your head on your pillow that night. It's just we're in such a soil moisture deficit that's been created by not only this drought, but again, looking at some of the snowtail data and seeing some of those diminished snowpacks. Even though we were at 95% snowpack, how that came off, it really didn't have a lot of time to slowly migrate, infiltrate, recharge like you normally would see. We went from anyone recall the last time it was 110 degrees in June? It's been a minute.
The 90s into May.
Yeah, right. Exactly. Yeah, those shoulder seasons continue to seem to want to grow on us and not in a good way. So, the only method that we have available, and I know conversations with your customers is tough. But trying to take and look at a regional approach to conservation, and as I mentioned about the soil moisture, this Droughtgov site, they're also in partnership with NASA, so they're actually using satellite technology to look at soil moisture content. And this is that 100-centimeter slice of where we're at with soil moisture. And I think when I did this was earlier in the week. August 5th. So it's real-time data that you see from this site. Well, we're less than 2%, under 2% of soil moisture content, 100 centimeters of soil. So it begins to paint that picture that anything that may fall isn't really going to do anything in the realm of recharge or put much of anything and flow into any rivers or local streams or lakes. So most of that's just going to hit the soil and be gone in no time. So what do we look at? I mean, how do we begin to have that conversation around conservation that works on a regional level? And I think, it needs to be socially acceptable. I think that people need to get their heads wrapped around the idea that, this is a path forward. It doesn't have to be, totally stop, curtail everything all at once, but how do we begin to begin that message that it has a social benefit. It has a net ecological benefit both to wildlife, stream flow, your aquatic folks, fish like kind of like water a little bit, and water that's not 80 degrees. We were talking to someone last night, and they mentioned that behind the impoundment at one of the dams on the Snake, and water temperatures at 72 degrees. Not a lot of steelhead like that, and that hits me right in the heart right there. But there's also that piece of capital cost avoidance, and I think that when we look at conservation, and one of the things I did to look at conservation was jump on everybody's website to see what they had to, maybe give me some pointers of direction. And I was really just kind of dismayed that there wasn't much out there in the world of websites that spoke much about conservation. I mean, there's a few sites. Terry's got some information on his website, and I think Whitworth had some. I don't know if Shane had a little bit on.
Just a little bit of stuff that goes to, yeah.
Yeah. But all in all, there wasn't really any consistent messaging. And I think really looking at that, that's kind of one of the things that we brought IWAC together for, was looking at that regional approach on how we can address some of those difficult conversations. And, when they originally did the camp studies, Terry, you recall, that was 2012, 2013, and their population, their growth projections, and their climate projections are way off base. You look at growth today, and I was telling Kenny and John when we were headed up Ramsey Road, we went up to another meeting earlier, and I said, this used to be fields, and you can't really distinguish Coeur d'Alene from Hayden Lake anymore just driving down the road. You have to look for the road sign now to find out where you are. But having that ability to kind of come back and reset the clock and say, okay, now what are we really looking at? How do we look at this from both maybe a demand forecast model regionally, and then applying that regional consortium or group approach. I mentioned earlier, probably a previous meeting, that there's a gal with GSI, Suzanne, that had done a consortium of sorts on the mid coast of Oregon, and where a group of purveyors got together because they needed to validate their water use before they could get any more water right. It's kind of how things kind of, so I get that pretty close.
Yeah,
Okay.
that's right. Yep.
That's kind of how Oregon rolls, a little bit different than what we're accustomed to up here, but the same thing. I think one of the struggles is how do we convey that message to our customer, because everyone looks at the Pacific Northwest and says, abundant resources, why conserve? Why do anything? And I think before we start to begin to drill new wells, because maybe our aquifer has dropped 2 or 3 feet, which can be the end all be all for some systems. I mean, most purveyors drill deep enough. They never drill, down to a depth that they have that built-in resiliency there. So, that aquifer level and make sure it remains static is pretty important. So how do we get this together and maximize those efforts with that regional approach? And by doing so, developing that emergency response and resiliency kind of footprint as well. And there's a lot of things that, we've done with the city of Spokane, with other water utilities in the Warren agreement, and ID Warren does the same thing on here, but is there piece and parts that would fit in this, regional plan as well? Because I think one of the biggest struggles to message this is that there's people that are very interested in conservation. There are people that they understand conservation, but unless it really impacts them fiscally, then we're okay. Right. And we know that if we want to raise rates, we're going to see conservation. But then we have the politicians come in and say, you're not doing that to my constituents. And I've been down that battle before. It's not a fun one. But being able to have that conversation to say, well, if we can avoid some capital costs and incorporate perhaps, a leak detection in a conservation plan, it may become more sellable. I was telling Kenny, we did that flyover by Utilis, they did the satellite leak detection. And, we had Spokane has a leak detection program in place, and they have, folks going out there every day to look for leaks, but it's kind of like throwing darts at the wall. There's no dartboard. And that's what that Utilis flyover really did, was allowed us to throw at a dartboard. And then if you have, just a few folks that could go out and look at those leaks or investigate those leaks, you're actually making some progress and some gains. So I think, when we look at conservation efforts here, maybe it's not what it looks like on the west side or in Oregon. Maybe it's, what we need to do here to be successful with purveyors both on the Washington and Idaho side. So I think that there's a lot of good opportunities there. But I think what we really struggle with right now is, what are we looking at conservation wise? Because we know that our demand forecast and some of that data is just, it's out of date. It was a little underestimated. Expected to see the type of growth that especially Coeur d'Alene's seen in the last year to 2 years. So